This is a PowerPoint on naming ionic compounds. So we're talking specifically about those compounds that bond ionically, not covalently at this point. And really that's all we've learned, so don't stress out about that distinction yet. So I'm going to teach you two types of naming ionic compounds. So we're going to start with what are called type 1 compounds. And those are any ionic compounds without transition metals. So, you know, that huge chunk in the middle that we keep kind of skipping over when we talk about trends, we're going to skip over them as well for type 1 ionic compounds. So type 1 ionic compounds are pretty easy to name. And we're going to break those down into two groups. We're going to talk about type 1 compounds without polyatomic ions, and then next we're going to talk about type 1 compounds with polyatomic ions. So if you remember from your atomic count sheet, polyatomic ions are ions that actually have more than one element in them. So like SO4 is sulfate, NO3 is nitrate, OH is hydroxide, that kind of thing. So as long as we don't have polyatomic ions though, the first step is just to name the cation, the positive ion. And then the second step is to name the anion, the negative ion, while changing the suffix to IDE. Now when we talked about trends of ionic charge, we said that nonmetals, which are the negative ion, the anion, their ion name ends in IDE. So if that's something you've remembered, then you sort of don't have to do step 2 because you already know that the anion is IDE. But if you don't remember that, it's something you have to remember to do. So let me just give you some examples. Like NaF is sodium, because that's the cation, fluoride. It's not sodium fluorine, it's sodium fluoride. Na2O is sodium oxide. Notice that with ionic compounds, we don't have to say anything about the fact that it's Na2. We just say sodium oxide. A couple of things. The reason we don't have to say anything with the 2 is because you know that sodium has a 1+ charge and oxygen has a 2- charge. So if these two elements have bonded, there must have been 2 sodiums. In other words, from the name, you can figure out how many sodiums and oxygens there were because you know the charges have to cancel. The second thing I want to say is that the oxide, you know, some of this is, you'll kind of pick it up as you go along. You might look at, you know, fluorine, and that's very clear that you change it to fluoride. Oxide, I know I have kids who say, why isn't it like oxyide or oxyide or something like that? Some of it's just convention. It's what sounds good. You know, for phosphorus we say phosphide, we don't say phosphoride. And I guess what I would say is don't stress out too much about that. You can always ask me, you know, hey, is this phosphide or is it phosphoride? And I'm happy to tell you that because clearly you have the concept down. Alright, so now let's look at type 1 compounds with polyatomic ions. So again, we're not looking at transition metals, but now we're going to look at things that have like an NH4 in them or an OH, something like that. So polyatomic ions, basically if there are single elements, because for example OH- could bond with an NH+, or I'm sorry, an Na+ sodium ion, then we still treat them exactly how we did before. So we would still just say sodium, or if it's, you know, NH4+ bonding with a Cl-, we would call the Cl- chloride. But then polyatomic ions are named, they're just given their name without changing any suffixes or anything. So if you have OH-, you have hydroxide. If you have CO3 2-, call it carbonate. If you have NH4+, we call it ammonium. And if you printed off the periodic table that has all the ionic charges on it, at the top there's a box that lists common polyatomic ions. If you haven't done that, I would really encourage you to, so that you have your own list, so that you're not sitting in class going, wait, how did you know CO3 2- was carbonate? How did you figure that out? Well, they figured it out by looking at their list. So if you don't want to print that particular list, do a Google search. If you just Google polyatomic ions, you'll come up with list after list after list. So let's try some examples. So KOH, for example, is potassium hydroxide, because the K is potassium, the OH minus is hydroxide. So you go ahead and name K2CO3 and go ahead and pause the video, and then when you have an answer, start the video again and see if you have the right answer. So for K2CO3, you should have gotten potassium carbonate. So now go ahead, well, let me just explain that, because the K2 is the potassium ion, CO3 2 minus is carbonate. So now go ahead and name NH4OH. You should have gotten ammonium, NH4 plus is ammonium, OH minus is hydroxide. Now name NH4Cl. You should have gotten ammonium from the NH4 plus. And then this is where you say chloride, because the Cl, it's not polyatomic. Poly means many. Chloride, chlorine, is just one atom. And so it's ammonium chloride. And I know some people say, well, how do you know that the N isn't by itself and the H4Cl is the polyatomic ion? Well, first of all, nitrogen is a nonmetal. And as we've talked about, we always put the positive ion first. We always start positively. So that's one way you know that. Another way is because you do have this list that I've asked you to print off, and you'll notice even if you haven't done that yet, these are all examples I gave you on the previous slide. And so you look at your list and you make some determinations. H4Cl is nowhere on the list. Don't assume that it's on some crazy list that you don't have access to. So some of it is, I would say, using your best judgment and thinking about what you have in front of you. So now we're going to go on to type 2 ionic compounds. These are ionic compounds with transition metals. So first of all, we're always, obviously when we're talking about transition metals, we're talking about metals, so these are always going to be positive ions. And what's a little different is that transition metals have more than one ionic charge. So if you look at that periodic table that I know some of you printed, you'll notice that a lot of the transition metals have, like, the box is divided in half, so iron has an Fe3 plus and an Fe2 plus. Copper has a Cu plus and a Cu2 plus. Just so you know, there's actually more charges than just what's listed. So I know chromium, for example, there's a 6 plus version that's not listed on your table because it's not as common. So because transition metals have more than one ionic charge, you kind of have to figure out which charge you're dealing with when you name it, because a Cu plus is going to bond to a Cl minus, but a Cu2 plus would bond to 2 Cl minuses to get it to cancel out, because as we talked about, the ionic charges need to balance out based on the formula. However, based on what we know of ionic bonds, we also know that like a CuCl is going to have different properties than a CuCl2. So that's why we need to know when we name it which version of this metal we're talking about. So what we do is we use Roman numerals to show the ionic charge of the transition metal. And here are some common Roman numerals. One is I is 1, II is 2, and so forth. You can write those down. So the Roman numerals, I'm going to say that again, show the charge of the transition metal. They don't say how many you have, they say what the charge of that metal is. So let's do some examples. So for example, CuCl. The best way to do this is to look first at the anion. So Cl is Cl minus. It is always Cl minus. It's never a transition metal because it's a non-metal. And based on the formula CuCl, I realize I have one Cu. So if I have one Cu and my Cl is 1 minus, then my Cu has got to be 1 plus, because those have to cancel out. So then I say copper 1. That 1 refers to the 1 plus, not how many coppers I have. As it happens, I have 1 copper, but that's not always the case. and then chloride is just how I named it before. So go ahead and try CuCl2. Pause the video and figure it out, and then when you think you've got the ions that make this up and the name, go ahead and start the video again. So the ions should have been, again, starting with the anion, we know that Cl is Cl minus, and we know we have two of them, so Cl minus, Cl minus, and that means the copper, because there's only one, has to be Cu2 plus. So if that wasn't what you got initially, maybe you try to rename it again. And so the name you should have gotten is copper 2, the 2 referring to the 2 plus, not the number of coppers, because in this case we only have one copper, copper 2 chloride. So now try CuO. So the ions you should have gotten were O2 minus, because that's what oxygen is, and then Cu2 plus, meaning the name is copper 2 oxide. Notice in both the second and third example it's copper 2, because in both cases we're talking about the copper 2 plus ion. So now do Cu2O. The ions you should have gotten are O2 minus and 2 Cus, so Cu plus and Cu plus, and so that is copper 1 oxide, because the Cu is copper 1, even though there's two of them. Please make sure you ask any questions on the note or on the comment section of these notes. I know that there's a lot here. The other thing is, if you want more practice, if you get online and just type in like naming ionic compounds practice or examples or problems, you're going to get more than enough examples. Unfortunately, this isn't actually in your book, so you can't use your book to get more examples.